All right, so that's working. It's already streaming, so I got the recorder on. It's already streaming, and here we go. Are there any questions from last Thursday? No questions about last Thursday? I'm going to assume that everybody has a chance to at least read the material up to the point where we left off. If you have not had a chance to do that, I strongly recommend to do that as soon as possible. It's important to read at least up to the material that I have taught, if not, reading ahead of me a little bit before class. Okay, so that's just kind of something that hopefully will help you get through this class and your other programming classes a little bit more easily. We do have our first homework assignment, so I'm going to go through the homework assignment a little bit, and then I'll do a little bit of demonstration. So this way, there's a little bit of you can watch the video and find out how to get started with your homework assignment. I'm just lowering the temperature of the of the classroom because this is a full class. Each person is like a 200-watt heater in terms of thermal output. So when you multiply 50 people by 200, you get what? 50 times 200 is 10,000 watts, right? Okay, let me double check my math. 200 times 50. So you get 3 zeros just from the zeros it's themselves. So if we have 10,000 watts of thermal output basically just from people. Huh? Oh, I don't know what the exact number is, but it's the order of magnitude that's important. So this is the same thing as running like 8 hair dryer like at full power, full heat setting, the whole time. Most people don't realize, when you use a hair dryer, you don't think about the heat output because you only turn it on for a few minutes. Okay, depending on the length of your hair and how dry you want it, it's between. Like I don't use a hair dryer at all, because my hair is disappearing, strangely, so I don't need to dry much. But if you try to turn on a hair dryer like for an hour, see what happens to the temperature of the bathroom. So we basically have the equivalence of about 8 of those in this classroom. And that's why I have to turn on the AC because, by the time it gets too hot, you guys will not be able to concentrate already. So there is that. So here's homework assignment 1. And I will go through this. Actually, this is what I'll do. There's a feature in Canvas that allows me to pretend to be a student. So student view, there we go. Excellent. So this way, what you see on the projector is pretty much what you will be seeing. So the steps that you have to go through should be about the same. So the first homework assignment looks like this, and this is going to be the format of all the future homework assignments. So by understanding this instruction and be able to follow the instructions, it's kind of important. So the first link here, okay, this link, follow this link to a shared Google spreadsheet, will bring you to a template spreadsheet that is a Google spreadsheet. So I'm going to follow this link. And the best way to do it is to right-click on it and open it as a new tab or open it as a new window. Depending on your screen size and whether you want to keep stuff, into the same browser window or not. So one or the other, it's up to you. I'm going to bring it to a new tab, which is this tab over here. So we'll take a quick look at that document first, okay? So this is a spreadsheet, as a starting point for your homework assignment. It has got 2 tabs, okay? So you can call each one of these a tab, or you can call each one of this a sheet of a spreadsheet document. So either way is fine. It's just a matter of how you want to call that. One tab is code, and the other tab is trace. The code tab is the instruction you're following. And the trace tab is where you want to keep track of the execution of the program. So if you, depending on how you want to do it, I'll show you later on, options of how to do this. There's a way for you so that you don't have to switch between the tabs all the time because you can open up multiple windows. You can have one window focusing on code and the other one focusing on trace, so you don't have to go switch between those two too often. Yes?
So trace is the execution of your result.
Yeah, I will show you what you have to put into the trace tab, in just a little bit. So right now, I just want to explain what you need to do for the first step, okay? And we can see that a lot of people, quite a few people are here already, but if you're not the owner of this spreadsheet, you cannot change it, okay? This is only shared so that you can view, but you cannot alter it. Because if you can alter it, then the whole class will be working on one single spreadsheet, and that's not going to work out very good, okay? So the way it's going to work is you have to make your own copy. All right, so to make your own copy, you have to go to File, and then you have to go to Make a Copy. Okay, looks pretty simple. But this is where you have to kind of stop and make sure that you kind of think about it and follow the steps accordingly. I don't really care how you want to name your spreadsheet as long as it is not offensive. Okay? So you can use a date, you can use your name, you can just leave it the way it is. Copy of assignment 1 is perfectly okay. Okay? The second part is where you have to be careful. Don't just click OK, because if you click OK at this point, then Google Spreadsheet will try to open or create a copy of this document in the same folder as the parent document, which is not going to work because this is inside a drive of my Google Drive, which you have no right permission. So you cannot create anything in my drive. So what you need to do is to go to the folder thing, click on the folder tab, or not the folder tab, but click on this little window drop-down box here. And at this point, it is still on my drive, okay? And this is what you will see as well, is you're gonna see folders on my drive. It is not gonna work, you cannot share into this folder. So what you need to do is to click on this little back arrow thing, and go all the way back to my drive. Okay, so make sure that you back all the way to this screen here that says my drive. So by the time it gets all the way back to my drive, it is going to be your actual drive. Okay, the second line of the instruction will tell you where you need to go to for your own drive. So once you get to my drive, then you can go forward again. And then it's up to you to create subfolders for documents of your various classes. Okay, if you don't really care about structure or directories, you can just put it right at the root of your drive. Okay, it might make things a little bit difficult to find later on. So I strongly recommend that you create subfolders for each class that you're taking. So all the material related to one class go to at one subfolder. Okay. So that's my advice, but you don't have to follow that advice. So for me, I just go to here, and if I want to create a subfolder, there's actually a button down here. I can't see it because my screen is not big enough to show that. But if you go down here, I think this one just says created. So those are the extra steps that you have to do in order to get it to work. Okay. So I think this button, can't see it. Let me see if I can make the screen a little bit bigger, and then I can scroll up later on to show you what I mean by that. Okay, so you can see I can navigate to a particular folder. Let's say this is the drive that I want. And let me try to move the entire window up a little bit so you can see. No, that's not going to work. Oh, that works. So when OK is not grayed out, then you can just click OK, and then the document will be created in that folder. But I can't really show you the entire thing just because the projector is not doesn't have enough pixels for that. So right here, this select here, this is actually select. If it is solid, it means we can actually put something over there. So I click select, and then click OK. And now, when it opens up as a new document, then you can actually work on this one. Now, how can you tell whether it is my document or your document, the copy of the original one? It's pretty easy to tell. If you're on this one here, okay, I'm already signed in as myself. Okay, let me sign in as somebody else. If I sign in as somebody other than the actual authoring account, you can see that it is view only. This is what you should be seeing when you follow that link. Once you have made your own copy, then it will look like this. Not only is the name of the document now copy of blah blah blah, you will also see that view only is gone because now it is in your drive. So are we okay so far with this instruction? Okay. So once you get here, okay, so getting back to the instruction of the assignment itself, there's a second line, okay? I know most of you have your own Google account, somewhere else. I want you to use the school Google account for assignments. So sign in to the Los Rios, Drive account, and there's a hyperlink here. I think it's really just apps.losrios.edu. That's where you need to go and sign in over there. And I want you to put your file over there. So the following stuff I just did. And then what you need to do is to look at the code in the code tab and then trace it in the trace tab. I will show you what I mean by code and trace later on with a different program. Okay. When you're all done, this is the standard for the trace part. We'll talk about this later on. I'll give you an actual example of how to do this. But after this is all done, at the end, then how do you turn in your homework assignment? When you're ready to submit the assignment, make sure your spreadsheet is shared with me. So that means you have to go to the copy of the original spreadsheet, click on share, and then use my ID here. It is W0006887. So once you have entered my employee ID in Los Rios, it should pop up my name, with my full, quote unquote email address. Okay. And then click that. And then just click send, and you're all done. Yep.
Could you repeat your number, your ID?
Huh?
Could you repeat your ID?
It is in the assignment instruction itself, so you don't have to copy it. It says it's in here. It's a part of it. Your assignment is actually, there's one more step, okay? After you share the document, you have to go to submit assignment, okay? Click on submit assignment, and you have to give me, actually it has a Google Drive thing. So I suppose you can just go to Google Drive. Okay, I'm masquerading now, so it doesn't let me do it. But I'm assuming that as an actual student, when you click on Google Drive, it will let you navigate to where the document is, and then you will be able to select a document and say, this is my submission. Okay, so it's actually easier on your side than I can illustrate as pretending to be a student. So are we good so far? Now, if you have any other question about how to submit a Google document as an assignment, you can probably just do a Google search, because Canvas is used on many campuses, and they have already done a lot of documentation of how to turn in an assignment as a Google document or a Google spreadsheet. So so far are we okay with the mechanics of turning in homework assignments? We good? Okay, all right, excellent. So the next thing I'm going to do is I'll give you an example, okay? So let me go to my original assignment here, and I'm going to make a copy of this because I want to give you an example, but I don't want to do the same homework assignment. So I'm going to make a copy of this, make a copy, and I'll use example 1 as the name, and I'll put it into the share folder too so you can actually find it. Click OK. So now we have a new document called example 1. So I'll just make some changes here. Change it to 5. change this to 6, and then change this to y plus x, but y plus 1, and change this one to x plus x, and the last one, oh, just let it stay. Okay. So this is the program that I need to, this is the code of what I will be tracing, in the next few minutes, okay? So obviously your program is different because I just made a whole bunch of changes to make sure that the example is different from your actual assignment. So one way you can do this is to open a new window so that you can have one screen to focus on just the code and another screen to focus on the trace. Okay. Now, if you don't mind switching between these two tabs all day long, hey, you can do that. Okay. But if you're like me and you go like, I don't think I want to do this all day long, then you can open a new window. So you can either do a plus here, open a new tab first, and then just copy and paste the link from the original one. So to go to this URL, just do a copy and paste to the new tab, and then press the enter key, and that works. Now we have two windows, this one and also this one referring to the same document. But they don't have to stay on the same tab. So one, I can go to the code tab, which tells me what code I need to execute, and then with the other one, it can remain on the trace tab. But then some of you are going to say, but this is still really inconvenient because I have to switch, instead of switching the tab of the spreadsheet, I'm now switching between the tabs of the browser. Okay? You can tear a tab of the browser out, just drag it outside of the window, now it becomes its own window. Okay? So once we can get it, once we are here, then you can have this one to only focus on the code, and then you move this one over to overlap as much as possible. So this way you can just kind of look at both at the same time. Is that okay? Does everybody understand how to do all the operations with your browser so that you have one window of your browser to look at the code and one window of the browser to look at the trace? Is this part okay? Yep.
Why we're not using two columns and say two sheets going back and forth to the sheets? We should do the trace on the second column.
No, you have to use a separate sheet. That is part of the instruction.
Any reason?
It's because I said so. Because in later homework assignments, the trace is going to be a lot longer than the code. So you're going to have to learn this technique anyway. So I want you to do it now. And anyone who says, but I don't want to do it, that's fine. You just won't get any points. You can do whatever you want, but I'm going to grade it according to the description of the assignment. Is that okay? All right. And I think I made the window too long because of a little bit of something I did earlier. Because I don't want to show you the tabs, just so that you can see which tab each window is on. There we go. All right. So are we still good at this point? It is still the same document, okay? So now we have to look at the standard of what a trace table looks like. And this is going to be the same kind of standard that we use for the rest of the semester. So what we are learning here is something that you basically have to reuse all semester long. So it's worthwhile to kind of understand what I'm expecting, what I want you to do in terms of the formatting. The leftmost column is almost all the time going to be a line number. And I personally don't like to spell out number because I don't want this column to be too wide. It's not such a problem, too much of a problem early on because we have plenty of space. As we start to get into parameters and subroutines and stuff like that, which is kind of like mid-semester, we'll be using a lot of width as far as the spreadsheet is concerned. So we want to make the columns as narrow as possible, and might as well start to practice it now. We also want to have one variable per column in addition to line number. Can someone tell me with this code what is the number of variables involved? Okay, we have x and y. There are two variables involved. So we have one column for x and one column for y. Strictly speaking, the ordering of the two variables is not too important. So if someone just give me like y and then the x, in a reverse order, it's okay. I'm not going to take any points off. The first row after the heading of the columns is always going to be labeled pre, which stands for precondition. The precondition role is basically telling us what can we assume about the variables before the program starts to execute. In other words, it's telling us what is the quote unquote initial condition of the program. This is a very important concept, and it is kind of slightly different depending on which programming language you're using. With a lot of scripting languages, variables do come with some quote unquote default value. But with a compiled programming language like C and C++, variables do not come with any specific initialized value. So they can be anything. We do not know what is the initial value. So unless I tell you you can assume these variables to have these particular values, they're always unknown. And we use a question mark to indicate that the values of x and y are both unknown prior to the execution of the program. Is that okay? Does everybody understand, not only what to do in the spreadsheet, but also the concept behind that? Okay? So after the pre, then we can start to work on the program. So we look at the program, line 1. Do I need to zoom in, or is that okay? The text is a little bit small. Zoom in a little bit? Okay. I can do that. Let's see, where's the zoom control? Oh, right here, percent here. So we can go for 125. Is that okay? Okay. Yeah, when we get to a later point of this class, this is going to be a problem for us because the projector only has so many, the resolution is limited, so I can't really magnify things beyond a certain point. But at this point, we can still do it. So what you want to do is to say, okay, I'm executing line 1. So on the line number column, indicate this is the result of line 1. Okay. So after line 1 executes, which variable is going to be changed? In other words, if you look at the assignment statement on line 1, what is the variable on the left-hand side? X. Okay, so the variable x is going to be changed. So we know that it's going to affect only column B, but not column C, because y is not mentioned. Okay, so what is the new value of x? How are we updating the value of x? It's going to be 5. Okay, because the right-hand side of the assignment, the left arrow specifies the new value of the variable. This one is easy. Okay, it does not involve any other variables. It's just a constant. So we just say, okay, x is now updated to a value of 5. So we put a 5 here. Yes?
Since the y didn't change, we put 0 or just leave blank?
Y is not changed, so y remains as unknown. We can just leave the question mark here. So any variable that is not impacted by a particular line, you can just leave it blank, because if you leave it blank, the assumption is it is not changed. Are we good so far? Okay. So this shows you that, if you look at any particular row in a trace, it's basically telling you at a particular slice of time, how we are changing a variable. So after we execute line 1, x is now updated from unknown to a value of 5. Yes?
I have a question.
Yes.
So, what if you skip
What if you skip
pre?
pre?
Yeah, and just
Then you will get points deducted. Because the line, this row here, which is labeled pre, is important. Because in some situations, I might tell you, you can make an assumption about the values of some variables. And in general, I do not want you to do that. But it is important to remember, unless you make assumptions, the value of variables are unknown. They're basically uninitialized. So you have to have a pre to indicate that.
Alright, so we always just start with pre and indicate the variables to unknown, and then line 1 is when we start changing.
Correct.
Okay.
So yep. So you always start with a pre, because you have to think about, can we make assumptions of the values of the variables? Yes.
Do we have to do an order, or can we start at a different point from?
In terms of the lines, it has to be sequential. That is a very important concept, because remember we talked about how most programming languages are sequential. That means you have to start from the beginning. And all programming languages that I know of, they're always from top to bottom. So in terms of the order of execution, it's always lines 1, 2, 3, 4, 5, and so on. Because we haven't really talked about loops or conditional statements yet, so without any type of flow altering constructs, it's always from top to bottom. So yes, you do have to follow the order of the line numbers. So all of those are good questions. Any additional questions before we move on to line 2? No questions? Okay. So let's move on to line 2 then. All right. So on line 2, what is happening? How do we track down, the execution of line 2?
X unknown.
Go ahead.
So y is being changed to 6?
Y is being changed to 6. Does anything happen to x?
No.
No. Nothing happens to x. We leave it blank. Okay.
Wait, is X not still 5?
X is still 5.
So,
But we don't write anything because it's not updated from 5 to something else. So we only indicate an update, and y is updated from unknown to 6. So this is how we track down the execution of line 1 and line 2. So because if we write down, if we just write down 5 here because it is maintaining the value of 5, that's going to take you guys a lot longer to finish the traces than it is necessary. So that's why I don't want you guys to keep copying the values when it's not changed. Because what if we have like 20 variables and each line is only changing 1? Then you're making, you have to copy the other 19 from row to row unnecessarily. Is that okay? All right. So I will not mark it wrong. Okay. So for those of you who insist and say, okay, since the value of x has not changed, it is still 5, I'm going to write a 5 here. You will not get points deducted, but it will take longer and it is unnecessary. All right, so we're moving on to line 3. So what do you think is happening on line 3? We are starting to have a little bit more interesting stuff here, because we have 2 variables involved, right? Which one is getting updated? X is getting updated. And what is the new value of x? It's 7, because currently y has a value of 6. So we evaluate the right-hand side first. 6 plus 1 is 7. 7 is the right-hand side value. It is used to update the left-hand side, which is x. So x now has a new value of 7. Okay, very good. Anything else we should do on this row? Yes?
could we just disregard the old previous value of X and just use the new one? We not like add them together.
Well, by doing it this way, we are now saying, x, the value of x is just updated from 5 to 7. Okay?
Just get rid of the old one. The old one doesn't matter.
Yes, the old one is no longer there. Now, when you look at a trace, you can look at a trace as as a reel of film, okay? And then each row is like a frame on the reel. So the current state is just row 5 in this case. So the current state is x has a value of 7 and y has a value of 6. Okay? But because we are tracking the history, we can also kind of roll back in time and say x used to have a value of 5 and then prior to that it was unknown. But that's only because we can roll back, the reel of film and locate a frame, at the very beginning. Okay, so that's a good question. But each variable can only keep track of one value at a time. All right, what about line 4? After we execute line 4, what is changed and how is it changed? Y is changed and y becomes 14 because according to line 4, we evaluate, it's an assignment operation. And with an assignment operation, we evaluate the right-hand side first. The right-hand side of line 4 says x plus x. So we look up x and we find that x currently has a value of 7. 7 plus 7 is 14. We are done with the right-hand side. Then we use that value to update the left-hand side. The left-hand side of line 4, the assignment operation, is y. So we know who is getting updated. Y is getting updated. So in the trace, column C is corresponding to the variable y. And as a result, variable y or column C is now updated to a value of 14. Is that okay? All right. So line 5, well, this time we go back and change x, right? So x is y plus 1. Y is 14 at this time. 14 plus 1 is 15. So x is now updated to a value of 15. Do we have any questions about this whole thing? No questions? This is all good? All right. So we are done with this trace. But there's one little thing I want you guys to do when you're all done with this. You write post. It indicates that this is it. Okay, I'm done executing the entire algorithm, and this is the result. Post is the short form of post condition, which refers to the condition of the variables after the entire program executes. So there's a pre, there's a post, and then in between we have the execution of the individual lines. This is the format I want you guys to follow. And you have to do it on Google Spreadsheet. So don't try to download it into Excel first and then work on it in Excel. Work on it in Google Spreadsheet. It is no harder to use Google Spreadsheet compared to Excel. Are there any questions about this? No? Okay, well, one more thing, after you turn in your homework assignment, after the due date, okay, do not go back and change a document any further, because I will look at the properties of the document. If I see it has been updated after the due date, I will not give that submission any points. You can go back and view, but don't change anything, okay? What if you accidentally hit something? I believe you can Control Z and undo it. And if you undo it, I'm not sure whether it records it or not. I don't think it would record it. Or if it does record it, I can tell. Yep. Well, because you're turning in a link to the document, taking a picture is not going to help you. Oh, you want to take a picture now? Absolutely. But it's getting recorded anyway, so, but if you want a double reassurance that you have it down, so that's fine.
Is there a YouTube link on Mojo?
Sorry?
Is there a YouTube link?
Yes, there's a YouTube link. So once, are you done with taking a picture? Are you? Yep, okay. So let me show you guys where to find the YouTube stuff, with this class. You go to YouTube and then /SomProfs, SOMEPROFS, some professors. It's an account that I created like a long time ago, like more than 10 years ago. This is where I keep all the lecture recording. And then what you do is go to videos. And actually, if you go to home, this is a live stream. And I turned off the private setting of live stream. So you can actually click on this, and I think it's about a 19-second lag behind real time. I mean, it's actually kind of funny to watch that too. So let's count. 2, 3, 4, 5, 14. So it's a 14-second delay. And then it will appear in itself and then appear in itself. It's kind of like an infinite mirror thing. It's really fun to watch, especially because it is so slow. So it is not only recorded, it is actually streamed to YouTube as we go. So this way I don't have to, there's no chance I can forget to upload it because it's already on YouTube as we speak. Well, 14 seconds in the future. Yes?
Do you suggest if we miss the lecture for any reason,
Uh-huh.
we watch the live stream?
You can use it for whatever purpose. Okay, if you have insomnia and you say I really need to find a way to fall asleep, you can watch my YouTube. I have been told that it's very effective, and there's no side effect other than you might wake up knowing a few things about programming, which to most people is not a negative thing. Or for those of you who have children to punish, you can say well, you have done something that I do not want, so now your punishment is to watch Dr. Tech's YouTube for half an hour. So you can use it for whatever purpose you want. One thing I do not advise is to think of using this to replace coming to class. Okay, so do not do that. That is the one thing I don't want you guys to do, is to think of using my YouTube to replace coming to class for two reasons. One, I'm going to take roll. Okay? So let me start on this side. And the second reason why I'm taking roll is because in class it's face-to-face and it's easy to ask questions. Okay? If you have a question, you raise your hand, and it's much faster, much more effective for me and the rest of the class to address that question when it's in real time. Okay? And I also find that most people who miss classes because they think they can just watch the YouTube usually ends up not really watching the YouTube, and they just kind of fall behind in class, and that's not a good thing. All right? So I have just shown you how to locate the video recording, and the resolution is actually pretty good. And for anyone who needs closed captioning, if you can wait about a day or so, YouTube does automated closed captioning, and I found that the closed captioning is actually super accurate, considering that I have accent and all kinds of weird noise going on. So it's actually not bad. Are there any other questions regarding the recording, and the trace itself? If we switch back to here, it's the trace. No questions? Okay, so I would strongly recommend that you start on this as soon as possible, so that on Thursday, if you absolutely get into a snag, okay, I cannot make a copy of the document, okay? I don't know how to share, or anything mechanical like that. You can bring that question on Thursday, and I'll be more than happy to address those questions. Okay, so start on it as early as possible so that I have at least one class to answer any questions related to what we are doing, what I have just done. Yep. It is due next Tuesday. So you have one class plus the entire weekend to work on it. And I don't think this is going to take much time. So are there any other questions about this?
Sorry.
Yeah.
So now when we share, do we share on this spreadsheet or on the other system?
So what you're sharing is you're sharing your spreadsheet with me. So you start with my spreadsheet, you make a copy of that to your own drive. You work on it as your own document. When you're all done, you share that document back with me, or you can just use the submission option of Canvas to turn in your
So
document.
we could do one of them, not just, so we can just submit it on the Canvas.
I believe when you submit it through Canvas, it automatically shares it.
Okay.
Yep. Any other questions? No other questions? All right. So if there are no other questions, we are done with this particular module. So let me go back to and point out which module I'm referring to. just have to leave student view. And that's the wrong class. Okay, so let's go back to this class here. So right now we are done with variables, assignment statements, and sequences. This is what we talked about last Thursday, and what I just illustrated today should be a review of what we did last Thursday. Okay. So now we're going to move on to conditions and conditional statements. So we'll open a new tab here. And I always start with a why, okay? Because to me, understanding why something is important is as important as that thing itself, okay? Because a lot of times the reason why we have something explains that thing pretty much kind of automatically. So right now, before this, okay, we have assignment statements, and we have the concept of a sequence. So you can have a whole sequence, long sequence of assignment statements. We have the concept of variables, so you can have as many variables as you want. But that alone cannot do even the simplest tasks of, oh, I give you two variables. Tell me which one is the larger one. You can't do that with just assignment statements, because assignment statements basically can only calculate a value or update a variable based on an expression. An expression, what kind of expression? Addition, subtraction, multiplication, division. So if I give you two variables, x and y, and I don't tell you ahead of time which one is larger, but I want you to write the code to determine which one is larger, there's no way you can do it with just assignment statements, because that involves a decision-making process, which also involves what we call a condition. So that's why we need conditions, which leads to conditional statements. So that part explains the why. So now we go into conditions. So a condition is basically a question. So when I mention a condition, you can, in your mind, you can just say, oh, okay, a condition is basically a question. But it's a little bit more specific than a general question, because a condition is a question that always ends up with an answer of either true or false. Now, I understand, the words true, false is not usually used in English. Instead, we use, yes or no, affirmative or, or not. But in programming, we use the values, true and false, to refer to the result of evaluating a condition. Okay. So this is actually not a very good question, because if I say, is variable x greater than variable y, the most natural answer to this is not true or false. It is yes or no, because that's how most people answer a yes blah 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 type of question. So just kind of keep in mind that we use true, false when we answer the questions. So that means, we are going to turn the question into a form kind of more like this. Is it true or false that x is greater than y? Then you are forced to only use one of those two words to answer the question. Either true, yes, it is true that x is greater than y, or it is false that x is greater than y. Is that okay? All right. So the first part of it is really just kind of emphasizing why we use the words true, false instead of the words yes, no. So without really getting into natural languages, I would just say that in some natural languages, they will answer a particular type of question with a no, when and some other languages will answer with a yes. Okay. I'll give you some examples, if anyone is interested, but it's ambiguous. Okay, natural languages can be ambiguous, and programming languages are designed to be not ambiguous. So we are moving on now to section 3.1. Now that we know that a condition is simply something that evaluates to either true or false. So the simplest type of operation that results in either true or false are comparisons. Okay, comparing basically two numerical values. I'm hoping that this is nothing new to the class, but I'll kind of go over this in a quick manner. We have greater than, less than, greater than or equal to, less than or equal to, not equal to. Okay, just a few things about notation at this point. Greater than or equal to, even though there are ways to enter this as a single character, it is cumbersome. Okay, so when I need you guys to express greater than or equal to, and if I need to express that in the code, I would use this symbol instead. It's a greater than followed by equal to, so there are two characters instead of just one. Greater than or equal to is greater than followed by an equal to symbol. This is also, by the way, what you use in most programming languages, so it's kind of universal in programming. So are we good with that notation? Okay. And the same thing with less than or equal to. It is expressed as less than followed by equal sign. Okay. Are we good so far with greater than or equal to, less than or equal to? Okay. Not equal to. The meaning is pretty clear. Okay. The two values are different. In C and C++, it uses this particular combination of punctuation to represent not equal to. The first one, if you cannot see it because it's kind of hard to see sometimes, is an exclamation point followed by a single equal symbol. That means not equal to in C and C++. But because many other programming languages like Java, JavaScript, PHP, I think Python to a certain extent also borrow operators from C and C++, they all kind of use not equal to as exclamation point equal to. I know it is kind of awkward and doesn't make sense in this class, but you might as well just start to get used to it because this is what you will see in the next class in CISP 360 and many classes after that too. In Visual Basic, SQL, Pascal, and so on, not equal to has a even more peculiar format. It does not even have equal to in as a part of it. It's less than greater than. But that's because not equal to is really the same thing as less than or greater than. So in a way it makes sense, but it's difficult to understand it, if you don't look at not equal to as less than or greater than. So it's just various ways to express the same thing. Equal to is just a single equal. It is important in the next class, not in this one. It is important for you to differentiate between a single equal symbol and a double equal symbol when you're actually writing C code. They mean entirely different things. Now, if they are syntactically incompatible, in other words, when you intend to use one but you put in the other one, it will give you a syntax error. It is not as much of a problem because you just have to fix it. Okay, the compiler will catch it and go like, "Hey, you are not allowed to use this symbol at this place." Unfortunately, in C and C++, where you can use a equal symbol, you can also use a double equal symbol, but they are doing entirely different things. A single equal symbol in C and C++ is what we use a left arrow for in this class. It is an assignment operation. It uses the right-hand side to update the left-hand side. That's what a single equal means in C and C++. A double equal is a comparison. It will evaluate the left-hand side, ends up with a value. It will evaluate the right-hand side, ends up with a value. And the question is, are they the same? Is it true or false that they are the same? Those two things are entirely different. One is just a comparison. No updates, nobody's supposed to change. Whereas the other one is supposed to change one, and the other side is not supposed to change. But in C and C++, where you can put an equal symbol, you can usually put a double equal. And where you can put a double equal, sometimes you can use a single equal in terms of the syntax. So it would be grammatically correct, but you have changed the program's meaning entirely. And those things are difficult to catch. Trust me. Okay, because I have programmed in C and C++ for years. Okay, and if the compiler doesn't warn me about these things, which they do now, okay, but in the earlier days, they do not. If I use one instead of the other one, the program looks right because they're very similar, especially when you're just kind of glancing through a program. But then your program will be behaving incorrectly. So that is one of the main reasons why in this class I use a left arrow to indicate assignment operation instead of a single equal symbol because that is just super confusing. Yep.
If you mix the two up, how would a program like behave like incorrectly? Like, can you give us an example?
Yeah, I can give you an example, but that relies on us knowing conditional statements already. So so maybe we have to hold it off a little bit. Okay. All right. So this is a topic really kind of should be discussed in 360, but if I get a chance, I will address it. Okay, since you asked. So once we have comparisons, we also have logical operators, but we'll defer the discussion of logical operators later, and instead, we'll talk about conditional statements. So I'm going to give you a problem to solve. Okay, and this is what we want to do. I'm just going to read it out loud. We'll try to express the logic to compute the maximum of two variables. So I give you two variables, x and y, and I won't tell you ahead of time what the values of x and y are, but I want you to give me the algorithm to find out what is the maximum between those two. Okay, so you obviously have to find out which one is larger first because that would become the maximum. And I want you to store the maximum value in variable z. So I give you x and y, those are the quote unquote input into your program, and I want variable z to become the maximum. Okay, just to go through a few examples to make sure everybody understands what the program is supposed to do. Okay. So if I give you, x, okay, so we have x, y, and z as three variables. If I tell you x has a value of 3, y has a value of 5, what do you think the value of z should be? Should be 5. Very good. Okay. And in the second scenario, if x, y, and y ends up this way, okay, this is an easy one, but I'll give you a harder one next time. Okay, so if x has a value of 5, y has a value of -1, what should the value of z be? 5. Okay, that's easy. Okay. What if both of them have the same value? What is the value of z supposed to be? 3. Okay, very good. The maximum of 3 and 3 is 3. Okay, very good. So we understand the concept of finding the maximum. Now the question is try to figure out how do we express that logic. So don't think about programming. Think about telling someone how to do something. Okay, so if there's someone else, okay, and you want to tell that person the logic of finding the maximum of two variables, how would you describe it? Go ahead.
Say if x is larger than y, then the maximum is the value of x,
Okay.
and if not, then the maximum is
Okay.
the value of y.
That makes sense. Okay. So I'm going to repeat to the class. Okay. If the value of x is greater than the value of y, then the maximum is going to be the value of x. If not, meaning if x is not greater than y, then the maximum would be the value of y. And whatever the value is, use it to update z because our intention is to put the maximum into z. Perfect. So as it turns out, in programming, we try to borrow words from natural languages, in this case, English. Okay, so this is how we express that logic. So let's check out whether it makes sense or not. Okay, if x is greater than y, then z gets the value of x. Else, which basically means what if the condition is false? Then z gets the value of y. And whoa, what is and if? We don't use that in natural languages, right? What do you think? What do you think is the purpose of and if? Say again?
Parsing out the conditional statement.
It just marks the end of the conditional statement. Okay, and that is actually one of the reasons why natural languages are confusing because the beginning and the end of a construct in a sentence is usually not clearly marked. So many times there are multiple ways to interpret where the beginning or how things are nested. But in programming, we don't want any confusion at all. Okay? So the if, the else, and the end if, they are parts of the same statement. Okay? They just serve different meanings. So from the perspective of a computer, the word if is kind of like flagging to the computer. It's like what follows is a conditional statement. Prepare to process a conditional statement. That's the purpose of the word if is to a computer. What follows the word if is usually, as far as most programming languages are concerned, what follows if is the condition. Remember what a condition is? It is a question that can only be answered with one of two possible values, true or false. Is that okay? The word then is nice to have, pseudocode programming languages because that's what we use. Okay, we use the word then a lot in a condition. In C and C++, they don't use that word then. Okay, there are very few programming languages that actually use the word then, but in pseudocode, I just keep it here because it just reads a little bit better. Is that okay? What follows the condition, and in this case also the word then, is what we call the then statement. What should we do if the condition turns out to be true? Well, it turns out we only got one little simple thing to do in this case, which is to update the value of z with the value of x. Okay, that's cool. The word else is significant. It marks the end of the then portion of the conditional statement, and also it marks the beginning of the else part of a conditional statement. The else part of a conditional statement tells the computer and us what to do when the condition is false. Is that okay? And in this case, it's simple. We only got one little thing to do. And then the words and if marks the entire thing. If you look at if as an open parenthesis to begin a conditional statement, the words and if serves as a closed parenthesis to indicate this is the end of a conditional statement. Is that okay? Yes?
So you have to rewrite line 1 because you write else.
I have to rewrite line 1?
So on line 1 it's saying x is greater than y.
No, it does not say that. It says if x is greater than y. In other words, this is a question. I don't know whether x really is greater than y or not. I'm asking a question. Okay? So that's an excellent question because it basically says this is not if you do not have any exposure to programming before, the meaning of these 5 lines can be a little bit tricky to understand. So instead of looking at it this way, let's see if we can use a picture to represent the same thing. So here's a picture of a conditional statement. So look at it as a trail path. Okay, you're going on a hiking trip. Okay, so you're looking at a map, and the map looks like this. Okay, so the condition is basically a little sign on the side of a road in the form of a question, where the answer can only be a true or a false. We okay so far? Okay. So for instance, did you bring along any food that can have trash left behind? That's the question on the sign. Okay? True, yes, I brought along, some potato chips and an apple. Okay? So I might generate some trash. In that case, the condition is true. Or, on the other hand, I may not have brought along any food at all. Okay? So the answer is no, I'm not going to be generating any trash. Is that okay? So based on the answer to this little question, the trail diverges, okay? If the answer to the question is true, you have to follow this side. If the answer to the question is false, you follow the other side. Is that okay? Well, this side where it is corresponding to true, there might be a little trash can somewhere on that trail. So that, if you generate a trash, there's a place to dispose of your trash. But the scenery may not be as good, because most people don't want a trash can, where, you have a nice view of something. The else branch, on the other hand, takes you to a vista point where the view is super nice. But they don't want you to have any trash because they don't want people to throw trash down, from the vista point, and who knows how many people are down there. Is that okay? But the two trails combine. So the two trails combine they merge, and then they exit this portion of the trail at the same spot. Are we okay so far with that interpretation as a trail map? Okay, here's a question. Well, if that is the case, can I take my trash, go here, throw away my trash, go back to this decision point, and then go, take a look, at the vista point? The answer is no. In real life, you would think you can do it, right? All of these paths are unidirectional. In other words, they're all one way. Once you get onto one path, you cannot back out of that path. So that's the other general rule of looking at a picture like this, representing the logic of the flow of a program, is they are all directional. Okay, each path is directional. You can only go in one direction. You cannot back out. Is that okay? All right. So if we have a construct like this, staying in the picture or pictorial format, let's see how we can come up with the answer to the question that we had a little bit earlier, to find the maximum and have z to store the maximum of x and y. Okay? And to do that, I'm going to actually draw a picture. So I'm going to switch to the tablet mode and use a really nice tool. I was told that this tool is no longer available for Windows, which is kind of not nice. But I don't use Windows, so I'm not going to have the problem. Page width, there we go. All right. So we'll draw the format, okay, the template of the path. Okay, we have one common place coming into this particular trail, and it diverges. It has two branches. One is labeled true, the other one is labeled false. True, this part has something to do, and then the false has something to do as well. But when we are done with these, the two parts of the trail merges into one single point to exit. Okay? So this is the general format of a conditional statement. All conditional statements look like this in a pictorial format. The only question is, what question are you asking here? What are you doing when the answer is true? What else are you doing if the answer is false? That's the only difference between instances of a conditional statement, but they all share the same format like this. So in this case, the question I'm going to ask, now there are different ways to solve this problem, but one easy way is to just ask, is x greater than y? Now, I have to be careful because if I just put a sign here and says x is greater than y, then there can be multiple interpretations, like are we confirming that x is greater than y, or are we making x greater than y? What are we doing here? So I'm going to put a question mark here, turn it into a question. So the question is it true or false that x is greater than y? That is what we are trying to find out with this sign. Is that okay? Okay. So on the left-hand side, how do we end up on the left-hand side? In other words, if I end up here, what does it mean? It means that it is true that x is greater than y. Okay, wait. we want to store the maximum of x and y into variable z. So what should I do here? Update z with x. Okay, very good. So z gets x. So we write this here. And this one would be z gets y. Right? So this is the pictorial format of exactly the same code that we saw earlier, except, hey, this looks easier to process because the direction, because it's pictorial. So here comes the question. How come we don't write programs like this? I mean, there are a few, kind of introductory programming languages like Scratch, that is pictorial. It gives you something that looks like this. But how come it does not become the actual professional programming language? It takes up a lot of space. Yeah, exactly. If you have ever programmed in Scratch or App Inventor, any one of those pictorial programming languages, you will also find that if you need to edit a program, sometimes you're making something a little bit longer, wider. How do you make space for that? You need to move everything else around it, right? And how do you find something? Because this is not linear, right? This is like, it goes on, in two-dimensional space. It's very hard to organize a program, physically organize a program when it's pictorial. Think about when you need to print it out. How do you print out a pictorial program? How wide do you need? How long do you need? We don't know. It depends on how that person wants to put things, in the program. So there are many reasons why we do not program pictorially. Okay? This is also not a flowchart. Okay? So in your future classes, if your professor asks you to give him or her an example of a flowchart, this is not a flowchart. This is text kind of hiking trail example, of a pictorial representation of logic. Okay? I don't like flowcharts at all. And this is a little bit better than flowchart. We'll talk about why this is actually a little bit better than flowchart. But do we have any questions about how this picture is really representing the same thing as the code that we saw earlier, which is this one here? Okay, let me see if I can bring those two side by side so we can look at both the text representation and the pictorial representation at the same time. Do we have any questions about how these two are representing the same thing? Any questions? No questions. Okay, excellent. So the next question is, how do we trace this? Okay, because it looks like sometimes we go for line 2 when x is in fact greater than y, and other times we will go for line 4 when x is not greater than y. So in a trace, how is this going to look like? And do we keep track of line 3? Do we keep track of line 5? So let's go ahead and do some examples. Okay. But before we move on to do some traces, do we have any questions conceptually about what a conditional statement is and how it works? No questions? Okay, all right. So let's go ahead and try to illustrate it using an example. I am going to be a little bit lazy and reuse this spreadsheet if that's okay with you guys. Okay. But instead of just stacking on top of what we have, I'm going to have additional tabs. So I'm going to name this one code 2, and then we'll have trace 2. There we go. So code 2 is going to be just that logic. So it's going to be if x is greater than y, then, and then here we'll have z gets x, else z gets y, and if. Oh, I forgot the line number column. That's okay. I can always insert now. So here are my line numbers. Oh, okay. Different spreadsheet does it differently depending on which one. Okay. All right. So this is the code of. I just replicated the same code. Um, Depending on which spreadsheet you're using, some would replace less than a dash with an actual left arrow. But in this class, it's okay just to leave it the way it is. So the less than and a dash really just means a left arrow, which is our assignment operator. Is that okay? All right. So now we need to trace it. Well, there will be multiple traces. Because there's no way to trace this unless we know what are the start values of x and y. So we'll do one here. Okay, we have line number. How many variables do we have? We have 3. We have x, y, which are the inputs, and then we have z, which is quote unquote the output. So we got x, y, z. And this is one of those cases where the precondition is kind of significant, because depending on what we know about x and y, the program or the pseudocode would behave differently. So let's just say that I tell you ahead of time. Don't ask me why, but x somehow starts with a value of 5, and y starts with a value of 3, okay, which is one of the examples we saw earlier. Z being the output variable is unknown, okay? Because we're going to change it so that it becomes the maximum of the other two. So I don't need to have an assumption of the value of z. Line 1 does execute, okay? But when it does execute, I have to do something now. So I need one additional column. So if you're copying, I'm sorry about keep making changes to the spreadsheet. But remember, this is all getting recorded. So if you cannot copy everything, it's still okay. I want to track the logic of this entire program. So what I need now is one additional thing. I just usually label it as comments, COMMENTS. Okay. And I got nothing to say about the precondition, but when I evaluate a condition like the one on line 1, I'm going to say x is greater than y is either true or false. So what do you think? Is x greater than y? It is true, right? So instead of writing true, I just use a T, because that saves some spaces. Do we have any questions about the execution of line 1? Because this is it. This is how we execute line 1. Oh, I just want to show you how to minimize the width of a column. You just double click, when your cursor is all the way to the edge of the selected column or columns, it turns into this symbol. When it turns into that symbol, if you double click, then all the columns that you have selected will be as narrow as they possibly can based on the content at the time. It's a little great tool to have, because I personally just do not like to use up too much space width-wise. Okay. Is line 1 going to change the values of any one of the variables, x, y, or z? No, because its only job is to say, let's compare. Let's see whether it is true or not that x is greater than y. Well, we got our answer here already. So that means none of the 3 columns, C, D, or E, is going to get changed, because nothing is getting changed. The next line is over here. So which line should I go next, now that we know that x is greater than y is true? Where should we go? We go to line, not line 5. Line 5 says we are done. We're not quite done yet. We go to line 2. Very good. We go to line 2 because line 2 is between the then and the else. That is where the then portion of a conditional statement is. It specifies what do we do if the condition of the conditional statement is true. Well, in this case, the condition of the conditional statement is in fact true, so we have to follow that. Is that okay? So we look at line 2, and we recognize line 2 is really just an assignment operation. So we evaluate the right-hand side, which is x. X has a value of 5. So the right-hand side of the assignment operation is 5. The left-hand side specifies z, so we know that z needs to be updated with the value of x, which is 5. So that is the effect of executing line 2. Where do we go next? Yes, go ahead.
I just had a question.
Yeah.
If it was false, would you go to line 4?
Yes, but we'll have another example to show what happens when it is false. Okay. So just focusing on this particular example, after line 2, what do we do? We just do a post. We're done. So this means and if or else are not traced. The reason why line 3 or line 5 is not traced is because they actually do not do anything. Okay? In terms of execution time, they do not serve a purpose. In terms of reading the code, they serve the purposes of else is the separator of the then from the else statements. Okay? That's the purpose of the else. And if serves the purpose of indicating where the conditional statement ends. In other words, in many ways, they are like punctuations. They are like a comma, a colon, a double quote in English. They do not get pronounced, when you are talking, okay? Because they're only there to serve as markers. Like this is the beginning of that, this is the end of that, and so on and so forth. So when we execute a code, we do not track down line 3 and 5. I know we are almost out of time, so I will address the other one really quickly. Okay, we add one more sheet. We'll call this trace 2.1 because it is kind of like the alternative of the other one. So we know that we need comments, we need line number, we need x, y, and z. The precondition this time is x is less than or equal to y. Okay, let's make them the same. 3, 3, okay? Z is unknown to begin with. We start execution on line 1. We perform the comparison. We indicate the answer. X is greater than y is false. Okay, very good. Okay, so it is false, which means we have to execute the else portion of the conditional statement. Which means where do we go from line 1? We go straight to line 4, okay? Because remember, else doesn't do anything, so we don't trace line 3. So line 4 is the actual line that we want to trace because it is the action that we need to perform. On line 4, it is an assignment operation. The right-hand side is y. Y has a value of 3, and we use it to update the value of z. So z now ends up with a value of 3. What do we do after line 4? Post. We're done. So this trace 2 and trace 2.1 illustrates the two scenarios of executing the same conditional statement. One tells you what to do when the condition is true, which is trace 2. One tells you what to do when the condition is false, which is trace 2.1. So I know what you guys are going to say, but I'm going to ask anyway. Are there any questions? No, because I need to go now. Okay. I'll see you guys on Thursday, but try to read ahead of me and jot down any questions that you might have, as you're reading ahead of me. Mm-hmm.
Sir, I have a question.
Yeah.
So for line,
Let me turn off the recorder first. I'm assuming that we don't need to record this.